Okay, so last time we went over bonding between ionic versus covalent bonding. So remember, you have your ionic bonds, and that's made up of your metals and your nonmetals. So in this case here, we have sodium, which is our metal, and then chlorine, which is our nonmetal. And you can see, right? Like sodium or your metal is going to be the one that gives away its electron, because if it gives away its valence electron, it'll have a full valence shell. And then your nonmetal will be the ones that want to gain an electron, because when nonmetals gain electrons, they get a full valence shell. So ionic bonds are always formed to reach that full octet. Same thing over here, right? You have your metal, which is magnesium. And this time magnesium wants to give away 2 valence electrons. So it'll give one away to one chlorine, and then the other one away to another chlorine to get that full valence shell. And again, for your ionic bonds, remember your charges need to cancel out to 0, right? So for example, here, sodium, you have Na plus, and then chlorine, you have Cl minus. So Na plus and Cl minus, those ionic charges will balance out to 0. And then same thing over here, you have Mg2 plus, and then here you have Cl minus, Cl minus. It'll balance out to 0. Okay, and yeah, just I guess the biggest fact that you would need to remember is metals, which are on the left side of the periodic table, will lose their electrons. And then the nonmetals will be the ones that want to gain electrons. Okay, so today we're talking about nomenclature. And now nomenclature just means like a system of names. So in general chemistry, there's just 2 systems of nomenclature generally that we go over. One of them is ionic bonding, and then the other one is for covalent bonding. If you get into organic chemistry, there's like another system of names. But don't worry about that for now. Just focus on these 2 for today. Actually, not even both of them. So on Thursday, we'll go over covalent bonding. So this time, we're only going to go over ionic bonding. And it's pretty straightforward. I would say the only thing that people get confused is if I ask you, like, if I give you a covalent compound and an ionic compound, remembering which rule is for which. So if we're just going over, like today's lesson will be pretty straightforward, I think, because we're only going to look at ionic bonds, but just remember to like, make sure to remember the rule specifically, or else it's going to kind of like, you're going to mix them up basically. So ionic bonds, ionic bonds are really easy. All you do is you literally write the name of the metal, and then you write the name of the nonmetal. Nonmetal with an IDE ending. Okay, so what do I mean by IDE ending? So let's just look at this example over here. Right here you have potassium. So potassium is your metal, and chlorine is your nonmetal. So I'm just going to write the name of the metal. So potassium. And then chlorine. Instead of writing chlorine, I'm going to end it in IDE. So instead of writing chlorine, I would write chloride. Okay, so you literally just get rid of the ending of whatever nonmetal you have and add IDE at the end. So for example, like chlorine would be chloride. Oxygen, you get rid of this ending. It would be oxide. Sulfur, you get rid of this ending, and you would have sulfide. So after you do a couple, it should kind of like click together. The next one, I'm going to actually give you a different one. So instead of MgS, I'll give you Na2S. And the reason for that is I just want to show you like the number of atoms that you have in ionic compound, it doesn't affect the naming at all. So for example, right, like sodium here, we have 2 sodiums, but it doesn't matter. You still write sodium which is your metal, and then sulfide, which is your non-metal. Okay, so if you want to make a note, you can. Like the number of atoms doesn't affect ionic nomenclature. You'll see that the number of atoms, it affects covalent nomenclature when we go over that lesson on Thursday. But ionic nomenclature, it doesn't really matter because, and if you want to get technical, this is the reason, because ionic, actually, it's okay. It'll make more sense when we go over covalent nomenclature. It doesn't make too much sense now. Okay, and then strontium nitride, this is just kind of what we went over with bonding, right? So this is like the reverse, writing the formula from the name. So strontium is Sr. And if you look, strontium should be in column 2, so Sr2 plus. And then nitride is nitrogen, so nitrogen would be N3 minus. So just have to balance out the charges to 0 again. So right now it balances out to -1. So if I add a strontium, this would make it to +1. Add a nitrogen, this makes it to -2. And then add another strontium, that'll cancel it out to 0, right? So your formula would be Sr, 3, and 2. Again, the subscripts kind of tell you how many of each substance or how many of each atom you have. Okay. So hopefully that made sense. I'm gonna give you guys about, so ignore this. I'm gonna give you guys about, I don't know, 2 minutes, 30 seconds, I guess, to do these 3. And sorry, I don't have a poll for it because I ran out of space on my polling software, but try this on your own, just like on a piece of paper or on your notes. And then I'll go over it in 2 minutes and 30 seconds. Okay, so it should have been pretty straightforward. So Al2O3, again, you just write the name of the metal and then the name of the nonmetal ending in IDE. So this would be aluminum oxide. The next one, right? So here you have potassium. And then fluorine would instead be fluoride. And then last one, this is kind of in reverse. So lithium has a 1+ charge. Oxide has a 2- charge. So we would need another lithium to get it to 0. So the overall formula would be Li2O. Okay, so hopefully that made sense. Now it gets a little bit trickier when we're going to talk about the transition metals. So remember, the transition metals are this block here. And it gets a little bit confusing. And the reason why is because if you look at all your other elements, they have set charges. So they only have one charge that they generally gravitate towards too, right? Like all the halogens will be -1. Everything under oxygen will be -2. All your alkali metals will be +1, etc. But if you look at your transition metals, you can see that a lot of them have multiple different charges, right? So like chromium has 2+ or 3+. Manganese has 2+ or 3+. Copper has +1 or +2. So when we're talking about transition metals, what we're going to do is if your transition metal has multiple possible charges, you're going to write the charge of the transition metal in Roman numerals. And your Roman numerals are listed here. Okay, and you would write that after the transition metal. So let me just show you an example, and then it'll kind of make more sense. So okay. So here you have FeCl3. And if you look here, right, iron can have two possible choices. You can either have iron 2+ or iron 3+. So you have to figure out which ionic charge that you have. So let me just show both examples. So if we had iron 2+, well, chlorine will always have a set charge of -1. So here we have 3 chlorines. And the trick is, remember, all ionic compounds have to have their ionic charges add up to 0. So if you look here, if I chose iron 2+, you can see it doesn't add up to 0. It adds up to -1. Right? But if I chose the other iron, so same thing, Cl-, Cl-, Cl-. If I chose iron 3+, you can see it adds up to 0. So whichever one adds up to 0, that'll be the correct transition metal. So this would have to be iron. And I know that my iron is a 3+ charge. So you would write that charge in Roman numerals. Iron 3, and then just write the normal name, chloride. Yeah, so next I could do another one for you guys. So here you have chromium and fluorine, and you technically don't even have to look at what your options are. So I'm not even going to look at my options, because if you know one of the charges of one of your atoms, you can always find out the charge of the other atom because it has to add up to 0, right? So here you have CrF2, and you know each fluorine has to have a -1 charge. And the overall has to add up to 0. So here, if you have chromium, right? I know since I only have one chromium atom, there's no other possible option. Like when you have ionic compounds, you can only have one possible option for your ionic charges because it always has to cancel out to 0. So this has to be chromium 2+ or +2. If it was chromium 3+, it wouldn't balance out to 0. It would be +1, right? So your name for this compound would be chromium. Sorry, this is hard to write. Chromium 2 fluoride. Okay, so why don't you guys take some time? I'm going to launch a poll for this. Try this one and this one on your own. Okay, so let's go over this. Nickel and oxygen. So again, I'm not even going to look at my options. I can just figure it out by because I know the set charge for oxygen. So oxygen is -2. And again, everything has to cancel out to 0. And since I only have one nickel, it has to be a +2 charge, right? So I know that since nickel is a transition metal, I would have nickel 2 oxide. Okay, and then for this one here, we have cobalt. So again, each oxygen is -2, and I have 3 of them. So O -2. And again, you need to balance out to 0. And here it tells you how many cobalts you have. You have 2 of them. So even though I don't know what charge I have yet, I know that each cobalt has to be, or that there's 2 cobalts. So if you look right here, right, you have to balance out to 0. These oxygens add up to -6. So whatever these charges are, it has to add up to +6. So you can cancel out to 0. So that means each cobalt has to be +3. Okay, and if they're +3, then everything should balance out to 0. Okay, so my overall formula would be cobalt 3 oxide. Okay, again, you write down the charge of whatever your transition metal is. So cobalt 3 oxide. If you wrote 2 oxide, you probably just wrote this 2 here, but that's wrong. It's the charge of the transition metal, not how many of the transition metal that you have. Okay, and then there's exceptions to the rule. So if you look here, right, even though silver, zinc, and technically also cadmium are transition metals, these are the only transition metals that don't use Roman numerals because they only have one set charge. So even though these are transition metals, they only have one set charge like your main group elements. So if you only have one set charge, you don't need Roman numerals. Again, because the Roman numerals are only there to indicate like which charge that you have. So for example, AgCl, this would just be silver chloride. Zinc and Cl, that would just be zinc chloride. There's no need to put like Roman numerals because again, these have a set charge, right? Ag, zinc, and cadmium. Okay. Give me a second. So last thing is the polyatomic ions. So we went over our polyatomic ions last time. They're like ions that are made up of polyatoms or multiple atoms. And these are your polyatomic ions. Again, you don't have to memorize it. If we were in person, we would memorize it, but we're not. So you can just use this chart. And then on the test, I'll give this to you as well. So polyatomic ions, it's the exact same rules as naming normal ionic compounds. The only exception is if you see a polyatomic ion, you write the name of the polyatomic ion. But if you don't see a polyatomic ion, you just write it like normal. And I'll give you a clue. Polyatomic ions usually end in ATE or ITE. Now there's obviously exceptions, right? So you see here hydroxide or cyanide, but generally speaking, they're going to end in ITE or ATE. So if you look here, right, nitrite, nitrate, sulfite, sulfate, phosphate, acetate, chlorate, chlorite, carbonate. So most of them end in ATE or ITE. Obviously, there's some exceptions. The ones that like people like to ask a lot is hydroxide and cyanide, but mainly hydroxide. Ammonium is also a common one that doesn't end in ATE or ITE. And again, you don't have to memorize it, but you just have to recognize when you see a polyatomic ion. And then obviously like normal nonmetal ions, remember they end in IDE. So for example, like sulfide is S2 minus, or oxide O2 minus, fluoride F minus. So just don't confuse the normal nonmetal ion endings with your polyatomic ion endings. So if I say sulfide, I'm talking about the normal sulfur, not like these. But if I say sulfite or sulfate, then you should know I'm talking about a polyatomic ion. So again, don't memorize it, but you should be able to recognize when you have a polyatomic ion. So let's just start going over this. So I'm going to kind of make two screens so you could see the polyatomic ions. Give me a second. Let me configure everything. Okay, so hopefully you could see this. I'll leave this up here. So these are your polyatomic ions. Okay, so let's write the names of these. So here you have calcium, and then you have SO3. So obviously, like, this is a big giveaway. You have a polyatomic ion. Because if you look here, everything else we did were like binary ionic bonds. So what that means is there are only two atoms, right? Potassium and chlorine, sodium and sulfur, or even here, we had iron and chlorine, or chromium and fluoride. So here we have like 3 atoms. So that tells you there's a polyatomic ion somewhere. So calcium, that's just our normal atom, or our normal metal. So I just write calcium. And then SO3, if you look here, you just look to see where you see SO3 on the chart. And again, you don't have a charge here because remember, when you connect a formula, you don't include the charges because they cancel out. So just look for wherever it says SO3. And if you look, you can see it says it right here, sulfite. So your name for this would just be calcium sulfite, and that would be it. So it's pretty straightforward. Just find whichever polyatomic ion you have. Yeah, and then again, just make sure you choose the correct one, because like if it said SO4, that would be sulfate, but it says SO3, so it's sulfite. Okay, next one here you have barium. So this would be barium. And then again, if you have parentheses, that's another big clue you have a polyatomic ion, because remember, you have to include parentheses to differentiate these subscripts. So PO4, if you look, where are you? Right here, PO4 3-. So this would be barium phosphate. And if you want to double check to make sure you chose the correct polyatomic ion, you can just balance out the charges and make sure they cancel out to 0, right? So for example, here you have calcium, which is 2+, and then sulfite is SO3 2-. So these charges, they balance out to 0. Same thing here with barium phosphate, right? So here, if I have barium and I have 3 bariums, so that would be, each barium is 2+. And then phosphate over here is PO4 3-. And here it says I have 2 of them. So PO4 3-, PO4 3-. You can see these charges will also balance out to 0. +6 minus 6 is equal to 0. Okay, and then next one, ammonium sulfide. So again, this IDE ending tells you you just have normal sulfur. So this should just be S2-, right? It doesn't say sulfite or sulfate. It says sulfide. And then ammonium is written right here, NH4+. Okay, so right now this balances out to -1. So you would need another ammonium. So your overall formula would be, let me write it right here, NH4 2S, because you have 2 ammoniums and 1 sulfur. Okay, I'm gonna launch a poll, and then why don't you guys try the next 3 on your own? Okay, so let's finish this up. Here you have calcium. That's your metal. And then OH2, again, the parentheses kind of tells you that this is a polyatomic ion. So if you look, right, this polyatomic ion would be hydroxide. So all you do is you just write calcium hydroxide. Okay, and then the next one is kind of, it's not really a trick question, but just one interesting thing is you have 2 polyatomic ions. So again, anytime you have a polyatomic ion, you just write the name of the polyatomic ion. So here you have NH4, so that would be ammonium. And then CO3, if you look, that should be carbonate, which is right here, CO3. So you would have ammonium, carbonate or carbonate. And then last one here is potassium phosphate. Again, this ATE ending tells you that you have a polyatomic ion. Okay, if it said phosphide, that would tell you that you just have phosphorus, like P3 minus. But the ATE tells you you have a polyatomic ion. So right here, you can see phosphate. So again, I'm going to just write down how many of each that I probably should have. So potassium is +1, and phosphate is PO4 3 minus. So right now, this adds up to -2. So again, balance out your charges to 0. So if I add another potassium or 2 more potassiums, that would change it to a charge of 0. So my overall formula for this would be K3PO4. That would be your answer. Okay, and that's pretty much it for this lesson.